Math 1108, Section 7.5, Applications with Rational Expressions. In Problem 1, doctors prescribe 13 milligrams of medicine for every 9 pounds of a child's weight. Find the amount of medicine for a child that weighs 54 pounds. This is an example of a proportion. This one, think of it this way. 13 milligrams is to 9 pounds, as X milligrams is to 54 pounds. The X represents the amount of medicine for a child that weighs 54 pounds. This proportion in words can be translated into an equation. 13 milligrams is to 9 pounds. I'll write that as 13 is to 9 without the units, as X is to 54. And then whenever two fractions are equal, the cross products are equal. One cross product is 9 times X. That's equal to the other cross product, 13 times 54. Think of 13 times 54 as 13 times 6 times 9. And then divide both sides of that equation by 9. We get X equals 13 times 6, or 78. So the child that weighs 54 pounds requires 78 milligrams of medication. In problem number 2, Gillian ran 12 miles from her house to the county line, and she got a ride on the return. It took 2 hours longer to run 12 miles than to ride 12 miles. Her run rate was 25 miles per hour slower than her ride rate. Find Gillian's run rate. Equations in this problem will have the form rate times time equals distance. There are two scenarios described. One scenario is Gillian running 12 miles, and the other scenario is Gillian riding 12 miles. We're supposed to find her run rate, so we'll write down an equation for when she's running that has the form rate times time equals distance. We're supposed to find her rate. I'll use X to represent her rate, X miles per hour, and T sub run for the amount of time it takes her to run 12 miles. And then she rode 12 miles on the return trip. We're told in this sentence right here, her run rate was 25 miles per hour slower than her ride rate. So her ride rate can be represented by X plus 25 miles per hour, and I'll write T sub ride to represent the amount of time it took her to ride 12 miles. In the second sentence, we're told that it took 2 hours longer to run 12 miles than to ride 12 miles. So we can note that T sub run, the amount of time it took her to run 12 miles, is greater than T sub ride, the amount of time it took her to ride 12 miles. That is greater by 2 hours. And so this can be converted into an equation. The larger number, T sub run, minus the smaller number, T sub ride, is equal to 2. Okay, so we'll solve each of those two equations for time. T sub run is 12 divided by X. Time is equal to distance divided by rate. T sub ride is equal to 12 divided by X plus 25. And then we'll substitute those quantities into this equation, and we'll get 12 over X minus 12 over X plus 25 equals 2. The least common multiple of the denominators, also called the least common denominator, is X times X plus 25, or it can be written as X squared plus 25X. And we will multiply the least common denominator on both sides of the equation. When you multiply the least common denominator by 12 over X, the X's cancel, and you're left with 12 times X plus 25. And then we're subtracting 12 over X plus 25 times the least common denominator. This time the X plus 25 factors cancel, so we just have minus 12X. And then on the right-hand side, 2 times the least common denominator is 2 times the quantity X squared plus 25X. Okay, so we'll do the multiplication. 12 times x plus 25 is 12x plus 300, and then minus 12x equals 2x squared plus 50x. The 12x minus 12x, those cancel each other out. So we'll subtract 300 from both sides to get 0 equals 2x squared plus 50x minus 300. Divide every term on both sides by 2. Since 2 is a common factor, we get 0 equals x squared plus 25x minus 150. This factors pretty nicely. X squared plus 25x minus 150 is x plus 30 times x minus 5. The two solutions to this equation are x equals negative 30 and x equals 5. In the context of the problem, only the positive solution makes sense. So Gillian's run rate was 5 miles per hour. Okay, and the next problem, this one is a work problem. This one says James can plant a garden in 8 hours, but if his daughter helps, the two of them can plant the garden in 6 hours. Find how long it would take James's daughter to plant the garden by herself. So as I was saying, it's a work problem. Equations in work problems of this sort are of the form rate times time equals 1, where 1 represents whatever job or task it is that they're trying to complete. Rate times time equals 1. So there are 3 scenarios. James can work by himself. They can work together. And the daughter can work by herself. We're supposed to find how long it takes the daughter to plant the garden by herself. Okay, so James can plant the garden in 8 hours, but if his daughter helps, the two of them can plant the garden in 6 hours. Find how long it would take James's daughter to plant the garden by herself. Okay, so James works at his rate, and in 8 hours he can plant 1 garden. So rate times time equals 1 for James. We're supposed to find how long it takes the daughter working by herself. So we'll use a variable such as t to represent the amount of time it takes the daughter to plant 1 garden by herself. And then when they work together, the working rate is James's rate plus the daughter's rate. And we're told that when they work together, they can plant 1 garden in 6 hours. Okay, so what we'll do is we'll solve each of the equations for the rates. James's rate is 1/8. That is, he can plant 1/8 of the garden per hour. When they work together, James's rate plus the daughter's rate is 1/6. They can plant, when they work together, 1/6 of the garden per hour. And for now, we're going to represent the daughter's rate by 1 over t. And then in this equation, we're going to replace James's rate with 1 over 8, the daughter's rate with 1 over t, and the sum of the rates is 1/6. The least common multiple of the denominators is just 24t. And so we'll multiply every term on both sides by 24t. When you multiply 24t times 1/8, you just get 3t. And then 1 over t times 24t, the t's cancel, and it's plus 24. And then on the right-hand side, 24t times 1/6 is 4t. Subtract 3t from both sides, we get 24 equals t. So the daughter takes 24 hours to plant the garden by herself, 24 hours. Okay, in number 4, Jenna flew 1,080 miles in a jet, and then she drove 240 miles in a car. The jet traveled 300 miles per hour faster than the car, and the car ride was 1 hour longer than the jet ride. Find the speed of the car. Okay, so this is another rate times time equals distance problem, and 2 scenarios are described. When Jenna flew in the jet, she flew 1,080 miles, and then when she drove in a car, she drove 240 miles. And we're supposed to find the speed of the car. So let's let x be the speed of the car, and t sub c is the amount of time it took her to drive 240 miles. And we're told that the jet traveled 300 miles per hour faster than the car. So for the jet, the rate will be represented by x plus 300. And for now, we'll use t sub j to represent the amount of time it took the jet to fly 1,080 miles. And then in the second part of the second sentence, we're told that the car ride was 1 hour longer. So that means the amount of time it took her to drive 240 miles is greater than the amount of time it took her to fly 1,080 miles. That's greater by 1. So we can convert this to an equation, subtract the smaller number from the larger number, and the difference is 1. Okay, so that means what we want to do is solve this equation for time. The amount of time it took the jet to travel 1,080 miles is 1,080 divided by the rate, distance divided by rate. And the amount of time it took the car to travel or to drive 240 miles is 240 miles divided by the rate. And then we'll substitute those two quantities into this equation. And our equation will be 240 over x minus 1,080 over x plus 300 equals 1. The least common multiple of the denominators is x times x plus 300, or x squared plus 300x. And then we'll multiply the least common denominator by every term on both sides of this equation. When we multiply the least common denominator by 240 over x, the x's cancel, so we'll just be left with 240 times x plus 300. And then when we multiply 1080 over x plus 300 by the least common denominator, the x plus 300 factors cancel, so we'll just have minus 1080x. And then on the right-hand side, 1 times the least common denominator is x equal to x squared plus 300x. Okay, so we'll multiply some things out. 240 times x plus 300 is 240x plus 72,000, and then minus 1080x equals x squared plus 300x. Let's go ahead and combine like terms on the left-hand side. We're going to get 72,000 and then minus 840x equals x squared plus 300x. And we'll add 840x to both sides and subtract 72,000 from both sides. So we'll get 0 equals x squared plus 1140x minus 72,000. Okay, well, this actually factors pretty nicely. It doesn't take too long to show that the two factors are x plus 1200 and x minus 60. You can tell by looking, negative 60 times 1200 is negative 72,000, and 1200 minus 60 is 1140. This equation has two solutions. One of the solutions is negative. The other solution is positive, so x equals 60 is the solution that we picked. If you remember, this is the rate of the car in miles per hour. So the speed of the car when traveling a distance of 240 miles was 60 miles per hour.